So if you recall from the first lecture we did, I gave you a course outline in that first slideshow. So I'm going to try to have a slide on here for the beginning of every lecture, just kind of show you where we are in the course outline. We won't necessarily follow this linearly, but we'll go ahead and have plan to cover every topic. And if we add something new, we'll have a different color anyhow. So this is Introduction to Python. And so those of you that already know Python, I'm sorry, you're going to get to listen to it again. Hopefully we'll make it slightly entertaining. Harika put these slides together, so I think they're better than the ones I've been lecturing off, because those were boring as all get out. But it's difficult to make a programming language introduction interesting. Let's start off with Jupyter. If you've gone and installed Anaconda, let's see. Then you should be able to go and type just down here in the search bar, type Jupyter Notebook. It'll pop up here, and it will bring up a console for Jupyter Notebook. And then it will pop open a tab in your web browser right here, which is the home for Jupyter Notebook. And this is all included, packaged in with Anaconda. And so in this notebook, you can then go ahead and start browsing your local drive. I've downloaded the file here for some of the Python data types, which we've put together for just some illustrations of some of the concepts out there. You can just download this and play around with it. How many people have Anaconda installed? How many people don't? A couple people. Okay. Yeah. It's like, I don't have time for that, huh? Yeah. No, anyhow. It's not that difficult. Again, Anaconda is real simple. You just go to anaconda.com or the Anaconda webpage. Just click a couple buttons. It'll ask you to register because, you know, everybody likes your email address these days. And then it'll download it, and it'll be just automatic setup for everything for you. So this is the toolbar in Jupyter Notebook. And you can see there's a bunch of nice, cute little icons up there. And you've got all the things you need to do. Save it, create a new block of text. It's all done in chunks of cells in here. So here's a cell that's marked down. Here's a cell that's listed as code. This is the output from the code cell, and right below it is when you run it, so on and so forth. So it's very straightforward. Cut, copy, paste, move things up and down so you can rearrange your code if you want to. Run, stop, reset block. And if you turn it on using the right directions, you can turn on a debugger and set breakpoints in your Jupyter, your code in Jupyter Notebook. And that's always very helpful to be able to set a breakpoint, watch point, check out what the variables are, watch them change as you're running the code, rather than having to add a bunch of print statements to it. So I've got a presentation, which I forgot to download this morning, but I'll go find it here later, that we talk about how to turn on the debugger in there. So you can also use Google Colab if you want to work with a team. Again, Google Colab is basically Jupyter Lab integrated with Google Drive. So you're just doing it out there on a shared drive. Google's managing that for you. It's helpful for your teams. Here's the interface for how to use that or how to find information about it. What is Python? A great old 1970s era TV show. That's what it was. There was a British comedy series called Monty Python's Flying Circus. Anybody that's seen Monty Python and the Life of Brian or Monty Python and the Holy Grail knows about the extreme silliness of that show. Well, Guido van Rossum lived in the Netherlands. He was a big fan of Monty Python's Flying Circus. So he invented a new programming language. He decided to name it after Monty Python. Open source from the beginning. It's called a high-level interpreted language. In other words, it's high level. You don't have to understand all the different hardware dependencies. You know, computers are different in the hardware because all the hardware manufacturers are trying to make money by selling you something that's special and different. It's interpreted, meaning that the code is evaluated on the fly. So you don't, if you have a program that's written in, say, C or C++, it actually has to load the entire program in, interpret it all at once, then change it into a separate file. It's executable, but you can't read it straightforward. But the Python is, it's actually technically hybrid compiled interpreted, because what it does is when you take a Python program and start to run it, the first thing it does is it shortens it down in what's called the Python bytecode. So it kind of shrinks it down into a faster format for execution, and then it interprets that Python bytecode. So it basically builds the tables, all the variables you've listed, things like that. Instead of using huge variable names, it just shortens them up and creates a table so you can find things. It's useful for scripting system maintenance tools. If you have a MacBook, huge chunks of the Mac OS run on Python or dependent on the Python that's included with the Mac OS. That's why one of the reasons why when you install Python on a MacBook, you have to be a little bit careful so you don't step on your system Python, right? So Linux, of course, uses it tremendously. It's getting more and more use in Windows as well. For instance, last year, Microsoft Excel released a Python package. You actually write a Python code inside a cell in your Excel spreadsheet, which is just kind of, I don't know. I could suppose you could go into that Python cell and tell it to load another Excel spreadsheet. You could have this inception thing where it gets recursive spreadsheets in Pythons. Yeah, it's got a huge set of libraries. That's the most powerful feature of Python because it's open source. Initially there was a language called Fortran that people were using for scientific programming. It was terrible. And when Python came along, all the people that were using Fortran were like, this is so much better. They ported everything they had into Python. So immediately created a huge library of useful stuff. And of course, Guido's a huge fan. And if we click on that, we'll get a link to YouTube where you can watch a Monty Python's introduction. We're not going to do that now because it's too silly. It is a silly place. Yes. There are several different ways to run Python. You can actually create a file, give it a .py extension, put a header on your Linux machine, tell it that it's a Python script, and just say Python and the name of the file. Or you can make it directly executable, make like a batch file in Windows, right? And so you just run that, and it'll run on its own in kind of a batch mode. And so that's what Mac is doing. They got these system utilities that are running in the background. They're cleaning things up, collecting logs, things like that. So you're not interacting with it. It just runs, right? You can also use what's called the Python console. This was included in the original release of Python. It's called the idle loop, interactive development loop environment. Actually, it's an homage to one of the Monty Python's flying circus actors named Eric Idle. So that's why, that's another Monty Python flying circuit Easter egg, I guess. And you just type in statements. So if you just go to the prompt and just type in 3 + 3, it'll give you 6, You can use an IDE, Jupyter, Spider, PyCharm, Visual Studio Code, Google Colab, and so on and so forth. So you're getting interactive things similar to that. Previously, you just type in 3 + 3, you get 6, but now you've got a history of everything you've typed in. You can go back to it, so on and so forth. So when you're developing code, one thing is inevitable, and that's bugs. Why are they called bugs? Because the first one was a literal bug. It was a moth back in the 1950s when Admiral Grace Hopper, was running the Naval Research Lab's giant mechanical computer, which ran on relays, clicking open and close, not transistors or integrated circuits. The thing stopped working one day, and they sent a technician in. They're crawling around in the system, and they eventually found stuck in relay number 70 in panel F, there was a moth. And ever since then, they started, people thought that was cute. We're going to call this bugging. So getting a bug out is called debugging. Yeah. There are 3 types of bugs. Syntax errors. So these are errors related to the structure or rules of the program, right? So if your program is not syntactically correct, it will not work. Example, print hello world. What's wrong with this? There are 2 things wrong with this statement. One of them is obvious. I've colored it red. But it's obvious if you're not in the back of the room. So that's why you should sit up front on the couch here, or the sofa. Anyhow, the other one is, in fact, this is not a quotation mark. This is a fancy, quotation that Microsoft likes to put on when you're trying to put things into PowerPoint, right? So it actually uses the backward-forward quotes. Python uses simple quotation marks. There are runtime errors or exceptions if it occurs during the program. So if you try to divide by 0, you will get an error. Semantic errors are errors in the logic where the computer will not know there's anything wrong, right? You will know there's something wrong, right? When you run the code, it doesn't work right. If I say the sum of 5 and 2 and then print out a minus b and I get, 3, I'll know something's wrong, right? Quick and dirty. Runtime errors, zero division error, division by 0 if we try to divide 5 by 0. If we try to say result equals string plus 10, right? I'm trying to add a string and an integer. And so I'll get an error. You can only concatenate string, not an integer to a string, right? So it says these are two different types. You can add things to a string. You can add two strings together, but you can't add a string and a number together, right? So it'll give you a runtime error. Here's another one. When an index is out of range, if I say print list of 5, okay, these indexes in a list are 0, 1, 2, 3, 4. So if I try to print lists of 5, it's going to give me a runtime error saying that index is out of range. If I have a dictionary, get into these a little more in there, but a dictionary, you reference things by a predefined label that you assign when you create it, right? So, or when you update it. So if I say print mydic sub c, I've only got an A and a B in there for my keys, and I'll get a runtime error. Key error C. Yeah, basically saying does not exist, right? When a non-existent attribute of an object is accessed, if I say num.append 5, append is not a thing you can do. These are the operators. Like, every function has both the operators that apply, and there's like this underlying that could be names, methods applied to it in object-oriented programming. So there's no append method to int, right? Import error. If I say import Thomas, I don't know who Thomas is, but Thomas is not around today, so we can't import Thomas, right? Thomas, I think, was a tank engine, right? Owen? Never mind. Okay. British children's show. Thomas is a little wooden tank engine that, yeah. Okay. CGI. File not found error. When you try to access a file that doesn't exist, say open file.txt is read-only, file1.txt does not exist, or it's in the wrong folder, right? So some people have submitted homeworks, and they don't give us the data file they used in the homework, and it's a little tough for us to run the code and verify that it works if we don't have the data file. Or they've gone out there and they've used the data file we've provided, and instead of just referencing it in the current directory, which is where we drop the code when we download it, they've put it into their own user WSUID document, so on and so forth. And we'll get an error, no such file or directory. Well, the file may exist, just elsewhere, not in the right path. This is a cute one. Math range error. When a calculation exceeds the maximum limit for numeric type. So if we say import math and we do math.exponent 1000, right? So we get an overflow, a range error. Just like when your calculator, you keep multiplying numbers until it runs out. When a program runs out of memory, large list equals 1 times 10 to the power of 10. So this is basically going to create a list. It's just full of ones. But so many ones that you should get an error. Depending on how much, computer memory you have, this could be a very large value to have to plug in there. Maximum recursion. If you do infinite recursion, where a function, you define a function and you call it itself. Fibonacci series, of course, is the classic recursive function. In this case, we have a recursive function that never ends. And so it'll just basically hit maximum recursion depth fairly quickly. Hello world. We got some syntax errors now we're going to get into. We can misspell the stuff in our text. That's fine. It's when our delimiters are wrong. When we, miss the quotation mark. That's a typo there. Unterminated string literal, right? So it says print hello world, and it doesn't know where the string was supposed to start, right? So it thinks that hello world is trying to interpret that as a variable, but doesn't exist, because you can just say print hello, and if there's a variable named hello, it'll print that out, right? But then it's starting a string literal here, and so it's all messed up syntax there. Some semantic errors, of course. We subtract instead of add. We can have an unbound local error. So if we say we define a function, we say print x, and then we say x equals 10. Well, the way Python works, it's an interpreted language. It doesn't go out there and do forward references, right? So it's saying, well, x is, is not associated with the value. Well, it is associated with the value, just not yet, right? So we got to think of our program as proceeding through time, top to bottom, right? And I've got burned by this in Jupyter Notebook, because when you run Jupyter Notebook, you open it up, you start running the cells. It starts with the first cell and second, so on and so forth. And then if you come back later and try to run it again, all that output is still there. So if you save the file, exit it, and then load it again later, you haven't actually executed that code in this particular session, but the output's still there. So you look at it, you think you've run it, and it says your variable is undefined. That's something you defined in a previous cell, right? You didn't run that cell again to define it again, right? So you can see things like this in Jupyter. Error handling. We can't really fix a syntax error, make our program. I mean, we have to fix a syntax error before our program can run, right? And a semantic error, where we've got an error, the code works, well, that's something we have to fix by putting in a test case, right? And making sure that it works as we expect. But exceptions, right? Runtime errors, there are ways to deal with them. Sometimes a runtime error is fatal if you just run your program with no error handlers, but you can create an error handler. So try x equals 5 divided by 0. And then if we put n there, instead of just saying x equals 5 by 0, we put that inside a try except. Then we say except 0 division error, we print cannot divide by 0. What does this do? All this does is make our program not die and keep going. So if you're writing code, for a customer, working over, of course, at NetApp for many years, we would develop software that was, managing storage. We didn't need that. We needed that not to stop, right? So we had all sorts of exceptions in there. If this thing goes wrong, we'd log an error and just keep on going, right? Because we had to get that data to the customer. We can handle multiple exceptions, right? So an example, we try num equals enter number, 10 equals num, except value error. If they don't input anything, we get invalid input, please enter a number. If they input a 0, we say we can't divide by 0. And then our code can keep on going. So of course, this is how you do user interactions and make sure that they type in something useful. You can also use else. If no exception occurs, or finally, always executes regardless of whether an exception occurred or not. So your try block can be fully fleshed out like this. Try to do something, except if I get this error. If I didn't get an error, I print out, okay, here, file not found. Otherwise, I could say, well, everything worked fine, right? Finally, once I've got the file read in, I can close the file, right? Or I can print out a message saying, we're done, right? Keywords have predefined meanings. Any programming language has to have certain words that are part of the language. So true, false, and, or, not, things like that are portions of the language. And so here's the total number of basic keywords in Python. Now, when you start importing libraries, you're going to start importing symbols with those libraries, right? And you don't want to step over someone else's symbols, but you are definitely not allowed to step over the keywords, right? Variables in Python. This is where you store the data you're going to work with, right? Obviously. So what are the rules for naming variables in Python? I should obscure this. Variable names can only contain letters, digits, and underscores. It cannot start with a digit. Can it start with an underscore? Yes, it can start with an underscore. Right? So it has to start with a letter or an underscore. In fact, inside Python, you will find what's called dunder variables, double underscore, underscore, underscore something. Those are variables that are internal to Python core modules and libraries. And you should not touch those. But Python has to have those symbols available to use. If you create a library yourself, with a bunch of methods, and you have some internal methods or internal storage you don't want anybody to use, put double underscore in front of it. That's just a simple indication that this is private. But it's global to you. You can use it freely. It's just, anybody else that tries to use it knows that they're breaking the rules. Just kind of one of those commitments, basically. You can wrap stuff up and make things private now, hide them on purpose. But when Python first started back in 1991, they didn't have all that fancy stuff, and all that original underlying stuff is still present in the language. Variable names are case sensitive. My_var and my_var are different. All right. And again, you can use Python keywords, especially if you capitalize them, right, as a variable name. But you should not do that. You don't want to confuse yourself. So don't say capital IF, right, or E capital LSE. Some examples of valid and invalid variable names. Current underscore balance is valid. Current minus balance is not. What is this? This is trying to subtract what's ever in the variable name balance from the variable that's in current, right? Hyphens are not in the variable name, it's separate. Current balance here and current space balance, again, those are just listing two variables. Those are not allowed in the variable name. Account for account. This is legal, this is not. Underscore 42. We all know that 42 is the meaning of life, the universe, and everything, at least if we're old people that have read Douglas Adams. 42 by itself is not a valid variable name. Total sum is valid. Total underscore $UM is not allowed. There are programming languages that use special characters in the variable names. One of them was called Perl. Is called Perl. It was hugely popular in the early 1990s, and Guido von Rossum hated all those little special characters. He also hated all those silly curly braces that the C programming language made you put in. And so, of course, he defined in Python, we're going to have simple variable names. We're not going to have any special characters in our variable names. And when we want to put a loop in, we want to indent it. And if you do your indentation wrong, right, then your code's not going to run. And I remember back in the day, I'm old enough to remember this, that people thought this was a ridiculous thing to do in a programming language, make white space meaningful. And it turned out that's one of the most powerful tools in Python. Because when we look at something as a person, we see the indentation. The computer doesn't usually care in other programming languages. You see a curly brace, or curly brace to start or close a if statement or something like that. And there was a huge class of bugs in the traditional C programming language where people would write code, they think they knew what it did, but because they'd left off the curly braces, C did something different than what they expected. In Python, what you see, what you get your spaces on there, your tabs, is what the code's going to do, and it will enforce if you make a mistake. Again, another string here. Sorry, got off on a tangent. Hello with characters around it. This is a string. This is not a variable. Some variables. We got an error here. Invalid decimal literal is what that's saying. If we say lambda equals 6, we say that's invalid syntax. Why? Because lambda is a keyword in Python. How many people know what lambda means in Python? Few people. Lambda is a keyword for making a nameless function. Ordinarily, if you want to create a function in Python, you say def and the function name. Well, sometimes you want to just have a throwaway function that's, just a few little short statements or something like that. So you can say lambda, and it'll actually drop a function right in there, call it, and then return, and you never see it. And that's basically, I think, as much we say about lambda in this lecture. We'll get into it more later. Operators are special symbols to perform operations on variables and values. There are many different types. Arithmetic, plus, minus, star, division, raising things to powers, comparison operators, and or not. Logical operators, bitwise operators, where you're actually taking the data, you're going way down into the guts, you're looking at that data as binary representation of it, and you're actually doing operations on the individual bits in that data. Assignment operators, anything you do, many of these operators, for instance, if I say x plus equals 3, and that's a shorthand for saying x equals x plus 3. So the assignment operator is nothing but a shorthand for, incrementing something by 3, whatever, right? Identity operators, check if things are the same or if they're equal. I mean, those are two different things. You can have, two different lists in Python, and the lists contain the exact same values, but they're two different lists. Or you can have something that references the same list from two different places. Membership operators, you build a set, you ask if something is in the set. You have a string, you ask if a word is in the string. And then there are special operators. So here are arithmetic operators, addition, subtraction, multiplication, division, modulus, floor division, and exponentiation. So what's here? Division, a/b is going to give you a floating point number. A/b is going to give you the largest integer less than the floating point value that the division would give you. So even though 3.75 rounds up to 4, it's going to floor it down to 3. And what happens if you do floor division with a negative number? I'll let you go load up Jupyter Notebook and ask yourself that if you care. Exponentiation, of course, 15 raised to the power of 4, right? And there's our outputs in there. Operators have a precedence, the arithmetic operators. I really am going to be amused when Harika is going to give this lecture tomorrow. And I want to hear how well she is able to say Punkt vor Strich. So operators are listed as a precedence in English. In American English, we say PEMDAS, parentheses, exponentiation, multiplication, division, addition, and subtraction. And many people get confused and think that's a one-for-one precedence, that multiplication is a higher precedence than division, and addition is a higher precedence than subtraction. It's not. So I put brackets around it to make it clear. In England, and I believe India, it's BODMAS, brackets, orders, division, multiplication, addition, subtraction, or BIDMAS, which I don't remember what I stands for, but anyhow. And then in German, it's just Punkt vor Strich, which means dots before slashes, because add and subtract are, slashes, and multiplication is just a dot or a splat, an asterisk. And division in German, when they write it, they don't do that little slash in the middle, they just write 2 colons. If you've seen ratios, 4:3, they just use that syntax in Germany, which I think is a lot shorter. Everybody says German is a long-winded language. I beg to differ. It can be. Beware of the unary minus. X equals 4 plus minus 3. Of course, the minus binds before the addition, but it actually binds after exponentiation. So if I say minus 4 star star 2, do I get minus 4 squared? Or do I get 4 squared and then negated? And the answer is I actually get 4 squared and then negate it, because the exponentiation happens before the unsigned, or the unary minus, right? So in any case, if you ever have any concern, just throw in a whole bunch of parentheses until it's clear what you mean. Fun, yay. Comparison operators used to compare values, return a Boolean result. A equals B. Does 10 equal 203? No. Does 10 not equal 203? Yes. Is 10 bigger than 203? No. Is 10 less than 203? Yes. And of course, greater than or equal, less than or equal. So those are the arithmetic comparisons. Logical operators, again, and, or, and not, are the big 3 on there. So if A is true and B is false. And again, in Python, thinking about integers, any number other than 0 is true. And 0 is false. So if I say, 3 and 5, it'll give me the first one of those numbers is not 0. Or it'll give me the last one of those numbers. We'll see that. Okay, so A and B is false. In this case, A or B is true and not A. Because A is true, we say not A, we get false. Operating on binary numbers. And again, we've got two numbers. We've lined them up. 10 is represented as 8 plus 2. And binary 4 is represented as just the number 4. 1, 2, 4, 8. And so we're basically taking and going down. And our result is doing the and, or, not, and XOR operators on each individual column if we line it up in a row. So here we see and nothing is on both of these. If we OR these, we see there's a 1, 1, 1, and a 0. If we say an XOR, it's the ones where they're different. If we say not A, it's going to flip all the bits. And so, yeah, what it's going to do is it's actually going to pad this out with ones, and then it turns it into a negative number when that top bit turns on. So it'll actually be 1, 1, 1, 1, 0, 1, 1, because it's complement. I am not sure that that was explained well. Left shift and right shift, you just move the bits around. Cool. Assignment operators. Again, A plus equals 3 just adds 3 to A. Minus equals 2, so on and so forth, right? You can use any of the operators with that. Identity, check if two things refer to the same memory location. So if I would create two lists, A equals 1, 2, 3, and B equals 1, 2, 3. Then I say C equals A. And the weird thing to see here is that A and B are clearly identical values, but they are two different lists. And when I say C equals A, I'm saying C go point to the same thing that A points to. So C and A are referring to the same object. Think of this as when I create a list, I'm creating a space someplace in the program, and that object exists there, and then I have a name for it, right? So when I say A equals 1, 2, 3, the thing is 1, 2, 3, and its name is A. The other thing is also 1, 2, 3, but it's in a different place. It has a name of B. And then when I say C here, I'm basically saying the thing that is referred to by A, let C be a second name for it. So A is C. Is says these are exactly the same thing. A and B look the same, but they're two different things. A and C are actually referring to the same thing. So therefore, A is not B and C is not B. Membership is something in the string. Is 2 in A? Yes. Is 5 in A? No. So if I say 5 not in A, I'll get it true. Statements in Python. These are the instructions the interpreter executes. Again, print hello world, x equals 10, y equals 20. Print statement where we're formatting things to show what the values are here. And we actually, you can see here, we don't actually have to create a variable to hold them. We can go ahead and do the calculation in what's called a format string here. Variable assignment. Updated value of A equals A, yes. And again, when we do the format, we put the print F. F indicates use a format string, and that means it looks for these special symbols inside the string and interprets them. And then you can actually put at the end of this a comma and even more modifications to the string format. One of the cool things about this is if I want to like print this with zeros, I could say, you know, bracket 0x or something, and it would pad it with zeros, things like that. So there's all sorts of things you can do with these format statements. Conditional statements, if x is bigger than 5, we print it if x is equal to 5, print this, and so on and so forth. So we would only get one of these statements here. You notice an if statement, you have any number of else ifs, you know, just keep testing things. And then finally, the last one, the else, is you're going to end your statement. Then after that indentation part is done, it'll be over. Functions created with a value with the word def. Def add numbers x and y returns the sum of x and y. We just return x and y. This right here with the triple quotes on both ends. That's what's called a doc string. When you define a function, a properly formatted document string causes that function to be self-documenting. If you're in the right IDE, you type in the function name to call it, and then hover the mouse over it, and it will pop up the help text that you wrote in to describe how that function works. And you can put in things there that like tell it what variables it's expecting, so on and so forth. So this is a very powerful tool, the doc string. And again, so result equals add numbers 10, 20, and then we print the result, right? And we could also say print f, the sum of 10 and 20 is, and then here we could put in add numbers 10, 20, right? Actually, we'd put end quote and then add that. So we can actually call the function in the print statement too. If we want to maintain the value for later, we have to do ahead, set it outside there. Print a for loop. For and while, the two different kinds of loops. For I in range 1 to 6. Range is a powerful tool, and actually we'll just create a list of numbers starting with the first value and ending before the last one, and you can have a step on there. So you could say 1, 6, 2, and it would go 1, 3, 5, so on. And it's and then we print out the square. While loop, same thing, except we have to maintain the counter ourselves, right? So while the count is less than or equal to 5 or less than 6, so we're going to get the same output, 1, 2, 3, 4, 5, the same range, but we did it manually here. And then, of course, we're printing squares versus cubes. Classes and objects, object-oriented programming. The whole goal of classes and objects is to hide information from other users so they don't accidentally screw things up, right? So in this case, I've got def underscore init is a underscore is a predefined name. That is, when you create a new member of a class, calc equals calculator, open close parentheses. This is a shortcut for init. So we'll call init. It will say, I have no values, so I'm going to use the default value of 0. Right? I'm going to assign that, and I'm going to be a thing, an object sitting in the program, and this is my value. When I add something to it, I add the value, right? So whatever my self value is, I just plus equals it, or I can subtract. Right? So after we add 10 and subtract 5, of course, the result is going to be 5. Import. When you need to find a function that you don't have, for instance, if you want to do a square root, you can't just do square root. You have to do math.squirt, SQRT, and it will take that value in there and give you the floating point representation of the square root. Exception handling, try result equals 10 over 0. We've already showed this. Again, if you run this code, it'll give you a warning. Return statements. In a function, if you don't have a line someplace in your function that says return, the function will return nothing, or not a number. So functions always return something, but sometimes that thing that it returns is basically says, I'm a useless value. You can't do anything with me. In this case, we return a plus b. You can have as many return functions and return statements in your function as you want. It just gets more confusing the more you put in there. Pass, do nothing. If you're writing code and you don't know what goes in this block, just put a pass, right? And then you can come back and fill it in later. If you go out onto ChatGPT and ask it to help you write a code to do something, you'll find, at least when I do it, I see pass statements in there. It says, I don't know how to do this part, right? So, maybe I'm asking the wrong questions. Maybe I'm asking it hard questions and it doesn't understand hard things. Yeah, that's more likely it. For I in range to 5, if I equals 3, break. So I'll print out 0, 1, 2, and then when I hit 3, it'll just quit, exit the loop. Or I can say continue, which is just skip this one. So there should be a space in here, 0, 1, and then we skip 2, 3, 4. And of course, the range stops 1 before the value that you give it. This is always the number starting at 0. So if you say range 5, it's going to give 5 numbers starting 0, 1, 2, 3, 4, and quit. Global and non-local statements. Global says, I want this to be global. Inside my function, by saying it's global, I'm going to go out there and reference the predefined function that's outside there. Ordinarily, if you have a function, you define a variable inside it, it will just go ahead and create a new one and override the outside, the reference to the outside. So you have a separate separate variable inside the function from outside. Same name, different variables, right? And delete takes things out of the list. And my time here. Good. Okay. My data types in Python. Again, there's numbers and sequences and mappings are the 3 different types. And what we're showing here is the operators have slightly different meanings in different cases here. So, integers, float, complex. We have, we can add numbers together. When we start adding strings to things like that, we're actually concatenating strings together. When we start adding tuples and ranges, we're actually adding the things that are inside the tuple, adding the things that are inside the list together. Quick and dirty, I'm going to check where I am in my slides here. Good, showing up on the end here. It's 40 out of 60. So yeah, everybody still awake? Okay, good. I'll tell Haruko she made some good slides, because by this time when I did the lecture last year on this old slides, I had people who were like snoring. Maybe it was someone who'd been out late the night before. That's it. Yeah. Strings or sequences of characters. You can either use single quotes or double quotes. They are immutable. Mutable means you can change it, you can mutate it, right? Immutable means you cannot change it. So once you create a string, you can't go out there and change the string. If you do something to a string, you can tweak it and put it in a new variable, but you can't change that thing. It is a chunk of data in your program someplace. It's fixed, right? And if you do something, you have to make a new one someplace else. So that's pretty straightforward. A list is a collection of ordered and mutable changeable items in Python. So you can store multiple items of different data types. It's ordered. The first thing you put in your list is its position 0. The second thing is at position 1, position 2, and so on. You can add, remove, and change things. You can have different types. Syntax, my list equals bracket, square bracket, 1, comma, hello, comma, 3.14, close bracket. I've initialized the list to have 3 items, an integer, a string, and a floating point. A tuple, on the other hand, is an ordered, immutable collection of elements. We initialize it with parentheses because we've got essentially the same thing, right? And why do we have a difference here? It's right there, that keyword mutable and immutable. If you want to create a list of things that you can't accidentally change, you use a tuple instead, right? So you're working with lists, you're adding, deleting things. You're taking a tuple, you're going through the tuple, you're reading things out of the tuple. You're not in there changing the tuples, right? So square bracket, parentheses, mutable, immutable. Many built-in methods, insert, pop, remove. Those are the things that are mutating the list, but those don't exist for tuples. It's fairly inefficient, consumes a lot of memory and storage. By making it immutable, you don't have to worry about tracking things that are changing, maintaining extra size for if your list grows, things like that. Your tuple's never going to grow. You know how much space you need when you create it, right? So it creates it takes up a lot less storage. And time efficiency, because again, everything is fixed. You know what it's going to be from now on until the end of the program, so it goes faster, right? A dictionary is an unordered mutable collection of key value pairs. So instead of accessing things by, list sub 0 or tuple sub 0, you're going to say dictionary fancy bracket and then give it a key. So for here, name is Alice, age is 25, city is New York. These are the keys, name, age, and city. These are the values, Alice, 25 in New York. And this is officially unordered. As of Python 3.7, it's ordered in the order in which you insert things. So if you create a dictionary and then you'll add things to it later, right? It will not sort them by, age comes before name and city comes before name. So not sort the keys in any sort of an alphabetical order. It will just maintain the order that you created them in. And that is brand new in the latest major versions of Python. Before that, it says I'm going to order these however the heck I feel like it internally, right? Use curly braces because it's a fancy list, right? So that's curly braces are fancy. Comments. You can start a comment with a octathorpe hashtag, right? Or what was the other name for that? And your comment symbol. Yeah, that's it. Anyhow, this is a single line comment, or at least it's actually a double comment. It does not end here. If I uncomment this here, this part would still be a comment. It would just be, a single line comment. I think this is actually there's a type lost a character, and that's probably what it is. And a multi-line comment enclosed with triple quotes, triple single quotes or triple double quotes, also called a doc string, and is useful for explaining your code, and it's useful for commenting. You got large chunks of code, right? If you're in Jupyter Notebook and you start typing in comment symbols, the text that's inside the comment will change color. That's kind of useful. You can tell when you've got something you've commented out the code you were actually expecting to execute. Python libraries are pre-written code, extend Python's functionality. NumPy is the core library for numerical computing in Python. So it provides support for arrays and matrices. Import NumPy as NP. We create this new data type called an array, which is a combination of lists and tuples, as it were. We can print array times 2. We can take that, multiply everything in the array times 2, and we'll actually print out 2, 4, 6. Pandas we're going to use that a lot in this class. It was designed for data manipulation and analysis, provides what's called a data frame, and data series for handling tabular data or time series data. Has support for data cleaning, merging, transformation. Import pandas as PD. df equals PD.data frame. We've created this using that data. Matplotlib is used for printing out animated, static, and interactive visualizations, plots, histograms, bar charts, lots of stuff. This is kind of the granddaddy one. There's other things out there called, like, say, Seaborn, things like that, or other graphics packages for Python, right? We got our plotlib, and this will try to figure out what we're doing. If I say plot.plot, and I'm going to get a scatter plot because I give it 2 dimensions. Right? TensorFlow from Google, end-to-end open source platform to do machine learning, supports deep learning and neural networks. This was the first real big, large AI project that anybody could use. This is deployable on multiple platforms. Again, we're just going to import TensorFlow and create stuff. That's just simple examples at this point. Scikit-learn is for doing machine learning and data mining. Tools for classification, regression, clustering. We're going to do regression, clustering, all these different tasks. And here we'll start with regression, then we'll go on to some variable selection. We'll do clustering, and then we'll do classification. It was kind of designed by people who worked with the NumPy and Pandas people, so it integrates very nicely with those. So for instance, if I want to do linear regression, I have 2 variables, x and y. I can just do model equals linear regression. Boom, there we go. TensorFlow and PyTorch is another one, which provides dynamic computation graphs for research. So you can combine TensorFlow and PyTorch to do some deep learning. Flask and Django are web development frameworks. So we can, basically build web pages on the fly. Requests is a library that you can do for using HTTP requests, get, post, put, delete. So you can actually go out there and start browsing the web using requests. Beautiful Soup is, of course, a reference to Lewis Carroll, Alice in Wonderland. It is out there recognizing that the internet is just a huge stew of random different formats, HTML, XML, SOAP, different formats for how the data is stored. Beautiful Soup tries to work with all of the different ones. Scrapy, similarly, for doing scraping of the web. So when you're going out there trying to find data in a semi-structured web page format, you can use these tools. Okay? Languages for data science. Again, in the early days, 1957, the programming language Fortran was developed. It was used for numerical computations and scientific applications. It had all kinds of weird little things in there. If you, if you named a variable with I, you didn't have to tell it was floating point. You just assumed that if the variable name started with I or J, it was a floating point number, right? Weird little things that today we're like, why was that in there, right? SQL came along in 1970. It was actually defined in 1970, and then Oracle finally made a product about it a few years later because it's designed as a theoretical language, and then someone actually had to implement how it would work for databases. And this is very powerful and very useful still. So we're, you'll want to know that if you're going to be in data science. SAS is another database management language. MATLAB, popular for numerical analysis. In 2000s or late 1990s to the 2000s, we saw the rise of statistical computing. So 1991, the R programming language came along, and so did Python in 1991. It took a little longer for it to take off. Python was originally seen as kind of like a, scripting language for maintaining your operating system, and Perl had that space sewed up for quite a few years. And eventually Python supplanted Perl for that. Java was defined by a company called Sun Microsystems, which was a wonderful company. And they're too bad they're not there anymore. They created so many wonderful tools for people that were open source. And then they got bought by Oracle. Anyhow, so this was write once, run anywhere, right? And was a goal of Java. And, it's a useful language. Unfortunately, the licensing from Oracle means that it's lost a lot of popularity. JavaScript, actually, it was ECMAScript originally, but Sun Microsystems thought it was kind of cool to do a tie-in, so they renamed it to JavaScript. They're completely different languages, Java and JavaScript, right? This is for web-based visualizations. You put this and you run this in your web page, and your browser can run that locally. So it's browser-based execution. Python gained traction because it's simplicity, straightforwardness. Simple things should be simple. The powerful libraries, it kind of slowly grew more and more. There's a lot of cross-pollination between Python and R. So we're, of this list, still today, Python, R, and of course, JavaScript isn't going anywhere for what it does, but using it for data science, not so much. The big data era, 2010 to 2020, Hadoop ecosystem, with all its strange names like pig and hive. Hadoop literally was named after the developer's 2-year-old son's toy elephant. Little boy had a stuffed elephant. He called it Hadoop. And so Dad, when he went ahead and made a product, an open source marketplace, he honored his son by naming his program Hadoop. Scala was released in 2013. This was created for Apache Spark, doing more fast data processing. Julia is a high-performance numerical analysis and computation language. Kotlin came along in 2016, was used for machine learning projects in the Android space from Google. Modern data science. Python has continued dominance. Frameworks like TensorFlow, PyTorch, scikit-learn, Pandas drive its use. These are all things with separate products, but libraries are created in Python to use these, right? R is advanced data visualization. Julia, Rust, and Go are emerging large-scale data pipelines. References to learn Python. Hey, this is the last slide. Yay. Python.org, your official Python documentation. Google has classes in Python, W3 Schools. There's a resource called, oops, I'm the wrong, Real Python, free code camp tutorials, so on and so forth. That is Python introduction. Here, if you go to Blackboard, under lecture slides and recordings, of course, the first lecture was last week, Tuesday and Wednesday. This is the second lecture, 127, 128, Introduction to Python. In this lecture, we've got the slides we just went through. And we've got this Python data types. Because it's already 12 o'clock, I'm going to go through this, not spend a lot of time on here, but I'm going to advise you to go ahead and download this and make sure you can run this. So here we've got introduction to strings, lists, tuples, and dictionaries. And these are just some things that Hardik put together as things you can do with these different data types. So for instance, if I want to create string and concat them together, I can type print string 1 plus an empty string plus string 2. If I just say print string 1 plus string 2, I'll get hello world with no space between them. Right? If I say print string 1 times 3, it'll repeat it. Some more, and there's more string methods. Strip white space, lower, upper, so on and so forth. And of course, these are not changing the string. They are just, taking the string, putting it through a filter, and then sending it to the print statement, right? Text to lower, forces everything to lowercase, force everything to uppercase, so on and so forth. Lists, we have different things we can do. We can add something to the end. We can stick something in the middle. We can pull something out. We can pop something off the list. And what the difference there is, remove just throws it away. Pop returns. So if I say x equals fruits.pop, I'll get whatever that was at that spot. Sort, we'll go ahead and put it in alphabetical lexicographical order. In our list operators for adding and multiplying. And again, multiplication, I say list times 2, it's going to go out there and actually duplicate the list. Tuples. Similarly to strings, are just fewer things we can do to it. We can't start changing things. Finally, dictionaries, we're out there getting the keys, getting the values, look at all the items in there, returning them as pairs. And again, these are tuples. This is the parentheses, so that's a tuple, a list of tuples. And finally, we can go ahead and just get the value for a particular key. So if I say get John, and I will get the value that's associated with John in that value. So there. So download that code, mess around with it. Let's see. Project. How are people doing on their teams? How many people have got the start of a team going? How many people are still looking for someone else to join their team? Have you got your name on the spreadsheet with a looking for more team members thing? Okay, so what I would advise you to do, if you have put your name on the spreadsheet, you say you're looking for more members. Again, those WSUIDs, it's kind of a random way to do it, but if you type in wsuid@wichita.edu, you will get an email address for that student. Okay, so just randomly pick a number on that list, say Are you interested in forming a team? This is my name. This is what I'm at, so on and so forth, right? And you can go ahead and send that out to more than one person, okay? If you want to meet people in the classroom and talk, I'll try to give you time here to chat before the next class starts and see what team you might like to be. Otherwise, if we assign the teams randomly, it's going to be the same thing. You're going to be with someone you don't know. You might as well just throw your name out there on the, on the spreadsheet and randomly contact someone and see if they're interested in forming a team with you. And another reminder, of course, on the project is that we are, as you get your team formed, start thinking about logos. And you can think about a logo, by yourself. If you have a clever idea, go ahead and put one together, right? And so we're going to be asking for logos here pretty soon. And this is just a fun, entertaining thing to do. We hope fun and entertaining. Finally, it is time for attendance. So before I go there, I want to make sure I don't have someone online here. I have one person online. Okay, so I go ahead and end the screen sharing here because, again, attendance is for being here in person. So as I get the key for doing the attendance today, I need to make sure that's only available to people that are in the class today. This is another silly little quiz. Copy the code. So go ahead and open up your Blackboard. And there's our access code to fill out the thing. Remember, this quiz is not graded. This quiz is simply, oh gosh, better get that off the screen, huh? I was going to give away the answers. This quiz is not graded, as in, you got to get those answers right. This quiz is just go ahead and fill out the answers, right or wrong, whatever you think you want to do. And then once you're done, you will count as having attended today's class. Okay, that is the number. While you're doing that, if anybody has any questions about Python, what we didn't cover, things that you thought I covered in too much detail, something like that, go ahead and let me know. And if anybody has any questions, oh, there's another thing I'm going to show. This is a spreadsheet I plan to get uploaded here today. Has the schedule for the semester as currently set. This is already on your first slide deck that we did last week. How many people have tried to load the slides from last week? The presentation, the recording, you tried to load the recording? I've been getting some questions from people saying, can I please access the recording? I'm not sure if we did something or if people are trying to log in as using a non-WSU ID account. But if people are logging in using their WSU ID and you're not able to access the recording, please let me know. Okay. Let's see, I think we can stop recording.